let's do some word problems that involve rational equations. So I'm going to do two different flavors. So the first one is a distance equals rate times time version. So usually your scenario is going to be it takes a total amount of time to get somewhere, or you're going to and from. Maybe a current example, working against the river. So I'll do two of those examples and then two work rate problems. So first off, so distance equals rate times time. I have to make a table for these, just keeps me grounded. So I'm going to come over here, I'm going to have my distance, my rate, my time. So Bob can row 8 miles per hour in still water, so out on a lake. The total time to travel downstream and return upstream to the starting point is 16 hours. Oh gosh, okay, so 16, I'm going to put that down here at the bottom under my time. I don't know what I'm going to do with the 8 yet. If the total distance downstream and back is 30 miles, oh, well that's 15 apiece then, isn't it? So down and up, I'm just kind of labeling as I go. Determine the speed of the river. Okay, well there's our unknown. Right, our unknown is the current, so C for the current of the river, the speed. Right? The river's just flowing and you're either working against it or it's working with you, it's helping you go faster. So when you're going downstream, you're going with the current, right, and it helps you. So, and he can go 8 just by himself. So if he's going downstream, his total rate going down is his 8 plus the speed of the current. Now when he's going upstream, so if he's working against the current, then his 8, right, it's lessened by whatever the current is doing, pulling him back. Okay, so there we go. We have, so far so good. Now how am I going to do that time? So it tells me that my total time is 16, but I don't, well, let's see. So distance equals rate times time. So distance equals rate times time. So we can solve this equation here for time, right? If I wanted to get time by itself, what I would do is I would divide both sides by r, right? So time is the same thing as d over r. So I'm going to write that for each of these situations. So going downstream, the time is 15 divided by 8 plus c. And going upstream, the time is 15 over 8 minus c. And then I know my total time is 16. Okay, so I've got something to go on. Here we go. So 15 over 8 plus c plus 15 over 8 minus c equals 16. Okay, so I have a rational equation. So remember how we do that. We come up with the LCD. 8 plus c times 8 minus c. Multiply both sides by that. So each of the terms gets multiplied by the LCD. So the first fraction, right, I'm going to 15, right, the 8 plus c's will cancel, so it's 15 times 8 minus c. So second fraction, right, the 8 minus c's will cancel, and so it's 15 times 8 plus c. And then 16, it didn't have any denominator, so 16 has to multiply the whole thing. 8 plus c times 8 minus c. Start writing a little bit smaller here, I think. So let's distribute. So I'm going to get 15. I'm going to use my calculator here. 15 times 8 is 120. Minus 15c plus 120 plus 15c equals 16 times, I'm going to multiply these two together first, so I'll get 64 minus 8c plus 8c, so those go away, then minus c squared. Let's see if I can fit this guy in here. So let's see, the left side, tidy up each side, so the 15c's will cancel. I'll have 240 for the left, equals, distribute the 16, so I have 16 times 64 is 1020. 1020. And then minus 16c squared. Sorry, scrunching it in here. So subtract 1020 from both sides. So I don't have a c to the first power, so I'm going to do my extract a root. So square root property. So I'm going to get my 16c squared all by itself. So subtract the 1020 from both sides. So 240 minus 1020 is negative 780 equals negative 16c squared. Divide both sides by negative 16. So c squared equals, I'm going to check my math real quick, because I have 780, and I don't really like that it's not a nice number. But maybe it's just not a nice number. No, 780 it is, divided by 16. Okay, there we go. So c squared is 48.75. So then we'll square root both sides. I'm just punching it into my calculator. So 6.98 miles per hour is C, which is the current of the river. All right. That's interesting. Okay, let's do the next one. Try to write a little bit smaller. So a car covered 120 miles at a certain speed. Had the train been able, so these are supposed to both be trains, I guess. So a train covered 120 miles at a certain speed. Had the train been able to travel 10 miles per hour faster, the trip would have been 2 hours shorter. How fast did the train go? So distance, rate, time. So 120, right, that's our distance for both cases. Had the train been able to travel 10 miles per hour faster? So we don't know the speed of the train, so that's our unknown. So R is going to be the rate of our train. So this is our slow version, and then our faster version. So in a certain amount of time, again, we don't know what that is, but if the train could have gone 10 miles per hour faster, so R plus 10, the trip would have been 2 hours shorter. So what do I want to do for this one? Do you know, I think I'm actually going to set this one up as a system of equations. Do you guys remember that? Let's see what that's going to do for us. So the first equation, 120 equals R times T. So I'm just doing the distance equals rate times time for each of our situations. So our slow equation, our fast option, 120 equals R plus 10 times T minus 2. So if we solve the top equation for R, so R equals 120 over T. I can plug 120 over T back into the other equation so that I'll get an equation that just has T's in it. So that's good. 120 equals 120 over T plus 10 times T minus 2. So we'll go ahead and FOIL. So I have 120 equals 120 minus 240 over T plus 10T minus 20. Okay, I know, take a deep breath, here we go. Just keep moving along. So I don't know if you guys saw that I have a positive 120 on the left and a positive 120 on the right. So I'm going to subtract 120 from both sides before I write down up here. So I'm going to subtract 120 and subtract 120 so that I have 0 equals negative 240 over t plus 10t minus 20. Okay, finally it looks like a rational equation. Multiply both sides by t to get rid of your denominator. T times 0 is 0. Negative 240, because the t's will cancel. I get a plus 10t squared minus 20t. I'm going to rewrite that so it looks a little bit nicer. So 10t squared minus 20t minus 240. Divide everybody by 10 just to make my numbers nicer. So t squared minus 2t minus 24. Factor t minus 6, t minus 4, t plus 4, sorry. So t equals 6, or t equals negative 4. Well, negative 4 wouldn't make sense. So t equals 6, so right, 6 hours. But it actually asks for how fast did the train go. So if t is 6, then the rate is 120 divided by 6. So the rate is 20 miles per hour. So if it had gone 10 miles per hour faster, so if it had gone 30 miles per hour, could have made the trip in 4 hours instead. Okay, oh boy. Work rate, and I've used all my space there. So the work rate formula. This is super important. This is the question, right, when you have people, right, if John can paint the house in 4 hours and Tim takes 2 hours more, how long would it take them working together? That kind of a question. So the formula looks like this, and I didn't leave myself nearly enough room. I'm going to put it on a sticky, so if you guys wrote smaller, that's great. Otherwise, another page of notes. So our work rate formula, T over A plus T over B equals 1. And then for formulas, we need to know what all of our letters stand for. So that T in the top, this is the time working together. The A, so one of the denominators is the time for one alone. And so one of the people or one of the machines working alone takes A time, and B is the time for the other one. So it's called work rate because if somebody takes 4 hours to do something, then every hour they do 1/4 of the job. So that's why it goes in the denominator there. Okay, so I'm going to scoot that up here, so I might have to look back at it. So the Austin blah 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 can purify the air in a conference room. I thought this one would be applicable for what the current situation is. Can purify the air in 15 fewer minutes than it takes something else. Together, the two machines can purify the air in 10 minutes. How long would it take each machine working alone to purify the air in the room? So for work rate, kind of like with my distance equals rate times time, I always start by writing down the formula because then I have a place to put the numbers that I find. So, together, 10 minutes. Right? They can do it together in 10 minutes. So that tells me that T equals 10. So I'm just going to start there. So 10 over A plus 10 over B equals 1. Now I have to figure, there's some sort of relationship between A and B. So A is the time, say, for the 400 machine, and B is the time for the 750 machine, okay? So the Austin the 400 can purify the air in 15 fewer minutes. So A is equal to B minus 15, right? So 15 fewer than the other machine. There's that relationship. So now go back to your equation, and instead of A, we're going to write B minus 15. So I have 10 over B minus 15 plus 10 over B equals 1. So here's our rational equation. So that means we need the common denominator. So B times B minus 15. Multiply everybody by that, right? What that does then is it's going to cancel our common denominators if we have them behind the other factor. So I have 10, the B minus 15 will cancel, so it's just 10 times B, plus 10 times, so the B's will cancel. B minus 15 equals 1. 1 didn't have any denominator, so it gets multiplied by everything. Okay, here we go. Let's go ahead and distribute everything, lay it all out there, see what we've got. So 10B plus 10B minus 150 equals, what do we have? My right side is B squared minus 15B. So it looks like I have a quadratic. So that means I need a 0. So let's go ahead and tidy the left side. And I'm sorry I'm all cramped in here. So 20B minus 150 equals B squared minus 15B. So subtract 20B from both sides. Add 150 to both sides. So 0 equals B squared minus 35B plus 150. So we're looking for numbers that will multiply to 150 and add to give me 35. Let's see. I'm just going to start guessing. I'm going to try 12. No. So I have 15 and 10. But that'll just get me to 25. So let's check my math real quick. 15 minutes fewer. So 50, checking, B squared minus 15B minus 15B. That goes together, 20B. Subtract it, minus 35B. Minus 150. It goes across. Okay, I'm going to pause and find my answer. Sorry about that. Took me a second. How about 5 and 30? So minus 5 minus 30. Okay, so that'll get me my negative 35B and my plus 150. Okay, here we go. So B can either be 5 or B could be 30. All right, so that's the time alone. Why does the 5 not make sense? Right, why do we have to go with the 30? Right, if we go with the 5, that would say that one of them could do it in less time. Well, if I tried to do 5 here, that would say that A did it in negative time. So B, the Argyle 750, takes 30 minutes. So 30 minutes for one, for the slower one, and 15 minutes for the faster one. Okay, last one. A certain pump can empty a pool in 42 minutes. A different pump can do the same job in 35 minutes. How long would it take the two pumps working together? T over A plus T over B is 1. A certain pump can empty, so this is one of the times alone, right? So we can let A be 42. A different pump, same job, in 35 minutes. How long would it take the two pumps working together? So T over 42 plus T over 35 equals 1. Well, okay, so now we have to find a common denominator. And you know what? I'm feeling that last one was kind of a rough problem, right? These have been some challenges, so I'm not even going to look for the smallest one. I'm just going to let the common denominator, I know it's not the smallest one, but my common denominator is just 42 times 35. So I'm going to multiply both sides by 42 times 35. So as it distributes on the left, right, the 42 cancels on the first one, 35t. When it multiplies the second one, the 35s cancel, so I get plus 42t. And on the right side, I just need to multiply those two together, so 42 times 35 is 1470. So then add those two together, so 35 plus 42 is 77t equals 1470. So divide by 77. So it looks like our time together would be 19 minutes and a little change, a little over 19 minutes.